Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The James Webb Space Telescope has just forced NASA to issue a red alert, and what it revealed is shaking the very foundations of modern cosmology. Far beyond the reach of human sight, Webb fixed its gaze on a seemingly ordinary patch of sky. What it captured was anything but ordinary. Entire galaxies appeared where, according to every model, they shouldn't exist. The universe, it seems, has been running ahead of our understanding, and humanity is only now catching up. Webb was designed to see light stretched across billions of years, to uncover the first stars and galaxies that flickered into existence after the Big Bang. But instead of faint, primitive clusters, the telescope revealed fully formed galaxies, massive and structured, existing at a time when the universe should have still been in its infancy. These were not simple gatherings of gas. They were sprawling cosmic cities, shining like beacons across space and time, demanding a radical rethink of everything scientists thought they knew about galaxy formation. Even more astonishing were the chemical signatures Webb detected. Within these distant galaxies and interstellar clouds, elements like carbon, oxygen, and nitrogen were present in abundance, far earlier than conventional models would allow. While this doesn't confirm life, it suggests that the ingredients for possibly life were scattered across the cosmos almost from the very beginning. If true, it hints at a universe much more fertile than previously imagined, where the seeds of biology could have been sown billions of years before Earth even existed. Then there were the black holes. Massive, gravitationally dominant, and present, far earlier than theory predicts. These objects challenge everything we thought we knew about cosmic evolution. Some may have formed almost instantly after the Big Bang, shaping galaxies and even the fabric of space-time itself. Others may hint at exotic possibilities: primordial black holes, cosmic strings, or regions where physics behaves differently. Whatever the explanation, the presence of such anomalies signals that the universe is far stranger and more dynamic than any textbook could prepare us for. The implications extend even further. Constants we've long taken as fixed, like the strength of gravity or the speed of light, might not have been constant in the early universe. Processes that should have taken billions of years could have unfolded in mere hundreds of millions, accelerating the formation of stars, galaxies, and chemical elements. If physics itself can evolve over time, then the rules guiding reality may be far more flexible than humanity ever imagined. This isn't just a scientific curiosity, it's a paradigm shift that challenges the very foundations of knowledge, and the potential for life adds another layer of wonder. If planets and complex chemistry existed this early, then civilizations could have arisen long before our own, evolved and vanished, leaving faint traces drifting through the cosmos. Life may not be a rare latecomer, but a natural early feature of the universe. Every spectrum Webb analyzes, every faint glow it captures, hints at the possibility that humanity is one chapter in an epic story stretching back far beyond Earth itself. NASA's red alert wasn't just about a surprise in the data. It was a recognition that our cosmic assumptions, the timeline of galaxies, the processes of star and planet formation, and even the constancy of physical laws may need to be reconsidered. Scientists around the world are now re-evaluating models, checking measurements, and debating what this accelerated cosmic history means. The universe, it seems, has been moving faster, organizing sooner, and glowing brighter than anyone anticipated. Ultimately, Webb's discovery is a reminder of the limits of human knowledge. For centuries, we've mapped the cosmos with precision, confident in the models built by Newton, Einstein, and countless others. Yet the universe has just whispered a simple truth. It is more complex, more mysterious, and more astonishing than our equations can capture. Every discovery is not the end of understanding, but a doorway to deeper questions. a prompt to look farther, think bigger, and embrace the unimaginable. The galaxies that shouldn't exist, the black holes that defy expectations, the chemical signatures that arrive too early, they are not contradictions. They are invitations to explore, to marvel, and to acknowledge that the universe is alive with secrets yet to be uncovered. Webb has done more than look into the past. It has shown us a universe that evolves, surprises, and challenges. NASA's red alert is not a warning of danger, but a call to wonder. Every photon streaming into Webb's mirrors carries messages from billions of years ago. And in those messages is a reminder: the story of the cosmos is still unfolding, and humanity is only beginning to read its first chapters. We do not yet know the full story, but one thing is certain: the universe is far vaster, stranger, and more magnificent than we have ever dared to imagine. Even more astonishing were the chemical signatures Webb detected. Within these distant galaxies and interstellar clouds, elements like carbon, oxygen, and nitrogen were present in surprising abundance far earlier than conventional models allow. While this doesn't confirm life, it suggests that the ingredients for planet sand, possibly for biology, were scattered across the universe almost from its very beginning. If true, it hints at a cosmos far more fertile than we ever imagined, where the building blocks for life could have been available billions of years before Earth even existed. The implications are staggering. Life may not be a late, rare occurrence, but a natural early feature of the universe. And then there were the black holes. Massive, gravitationally dominant, and present far earlier than theory predicts. These objects challenge everything we know about cosmic evolution. Some may have formed almost instantly after the Big Bang, shaping galaxies and even influencing the very fabric of space-time. Others hint at possibilities so exotic that scientists are only beginning to speculate. Primordial black holes, cosmic strings, or regions where physics itself behaves differently. Whatever the explanation, the presence of such anomalies signals that the universe is far stranger and more dynamic than any textbook could prepare us for. The discoveries extend even further. The constants of nature we've long regarded as fixed, like the gravitational constant or the speed of light, may not have been so constant in the early universe. Processes that we thought would take billions of years may have unfolded in just hundreds of millions. Stars, galaxies, and even heavy elements could have formed with astonishing speed. If physical laws themselves can evolve over cosmic time, the rules guiding reality may be far more flexible than humanity has ever imagined. This isn't a mere scientific curiosity. It's a paradigm shift that challenges the very foundations of knowledge. Webb's findings also raise the possibility of life arising much earlier than expected. If planets and complex chemistry existed in the infant universe, then civilizations could have emerged, evolved, and vanished long before Earth even formed. Faint traces of these ancient worlds could still drift across space, invisible but present, waiting for instruments like Webb to reveal them. Every spectrum, every faint glow, hints at a universe rich with potential. A cosmos that may have been seeding intelligence almost from the start. NASA's red alert was not issued lightly. It signified more than surprise. It represented a recognition that humanity's cosmic assumptions might need to be reconsidered. Galaxy formation, star formation, the timeline of chemical enrichment, and even the constancy of physical laws could all be subject to revision. Scientists worldwide are now re-evaluating models, scrutinizing every pixel of data, and debating what this accelerated cosmic history truly means. The universe, it appears, has been moving faster, organizing sooner, and glowing brighter than anyone anticipated, yet the implications stretch beyond astrophysics. Philosophers and theologians alike are confronted with a cosmos that refuses to be constrained by linear timelines or human expectations. If complexity erupted almost immediately after the Big Bang, then existence itself may not be a rare accident, but an inevitable outcome of the universe's unfolding. Civilizations may have risen, flourished, and vanished long before humanity's first steps on Earth. The echoes of those ancient societies could still drift across the cosmos. perhaps in the form of subtle energy signatures, gravitational waves, or as yet undetectable remnants awaiting discovery. Webb's revelations also challenge our understanding of order and chaos. The infant universe was expected to be turbulent, a jumble of matter slowly coalescing. Instead, the telescope captured galaxies exhibiting defined spirals and organized elliptical forms, as if cosmic architecture was unfolding far faster than theory allowed. Gravity, structure, and cosmic design appear to act with astonishing efficiency, perhaps influenced by unknown forces guiding matter into coherent forms. It seems the universe may be predisposed toward order, revealing principles of cosmic organization that we are only beginning to understand. Chemical discoveries in planetary atmospheres amplify the intrigue. Webb's instruments detected molecules like methane, carbon dioxide, and traces of water vapor in systems orbiting stars. The James Webb Space Telescope has just forced NASA to issue a red alert, a signal that the cosmos has done something utterly unexpected. Far beyond the limits of human sight, Webb focused on a patch of sky that had seemed ordinary. But what streamed back across billions of years was anything but ordinary. Entire galaxies appeared where every model of cosmic evolution predicted nothing should yet exist. The universe, it seems, has been running ahead of our understanding, revealing a story far richer and stranger than humanity ever imagined. Webb was designed for the pursuit of cosmic firsts, to see the faintest light, traveling for billions of years, to uncover the birth of stars and the earliest galaxies after the Big Bang. For decades, astronomers believed that the early universe would be chaotic, small, and dim. A sparse playground of scattered gas and infant stars gradually building up into larger structures. What Webb revealed was entirely different. These galaxies were not faint hints of structure, they were massive, organized, and astonishingly luminous, appearing billions of years sooner than the models allowed. The universe seemed to have fast-forwarded, assembling intricate galactic cities almost instantly. Even more extraordinary were the chemical signatures Webb detected. Carbon, oxygen, nitrogen, and other heavy elements previously believed to require successive generations of stars to form appeared in abundance. These elements, essential for planets and potentially for life itself, suggest that the universe began preparing the stage for biology far earlier than anyone thought. While we cannot claim life exists there, the ingredients for complexity were in place, forming a cosmic kitchen billions of years before Earth even coalesced. Imagine a universe where the seeds of life were scattered almost from the beginning, silently waiting for the right conditions to ignite. The black hole's Webb revealed add another layer of intrigue. Massive, gravitationally dominant, and already present in the early universe, they defy expectations of how quickly such objects could grow. Normally, black holes form from collapsing stars and accumulate mass over billions of years. Yet Webb shows them already at staggering sizes mere hundreds of millions of years after the Big Bang. Some may have formed from direct collapse mechanisms, and others may hint at exotic physics primordial black holes, cosmic strings, or regions, where the laws of nature differ entirely. Each possibility points to a universe far more dynamic and unpredictable than previously imagined. The red alert issued by NASA isn't merely a caution, it's an acknowledgement that the very rules we assumed to govern the cosmos might need revising. Constants we believed immutable: the speed of light, the strength of gravity, the behavior of quantum fields may have been slightly different in the early universe. Such changes could explain how massive galaxies and heavy elements formed so rapidly. This is not idle speculation. It is a recognition that our understanding of fundamental physics could be incomplete. If true, the implications extend far beyond astronomy, potentially reshaping our grasp of energy, matter, and the evolution of the cosmos itself. The possibility of life emerges as another profound question. Webb's infrared instruments reveal chemical fingerprints in planetary systems orbiting stars thousands of light-years away. Methane, carbon dioxide, traces of water vapor appear at times and in places previously thought impossible. Could planets capable of sustaining life have existed while our Milky Way itself was still forming? could civilizations have arisen, evolved, and vanished long before humanity took its first steps? Every observation hints at a universe rich in potential, where life may be abundant and ancient, embedded in the very architecture of creation. Webb's observations of gravitational distortions deepen the mystery even further. Light bending around unseen massive structures implies the presence of enormous black holes or other exotic concentrations of matter. Yet these objects existed at an epoch when conventional theory predicts they should be impossible. To reach such masses requires time that the universe hadn't yet had. These ancient giants may not simply be outliers, they could be central to the formation of cosmic structure, shaping galaxies and influencing the flow of matter and energy across vast distances. In this sense, black holes may not be end of collapse, but fundamental scaffolding for the universe itself. Speculative physics opens the door to ideas previously confined to theory. If the constants of nature were not fixed, then cosmic evolution might have proceeded with extraordinary rapidity. Galaxies could assemble almost overnight. Stars could forge heavy elements with shocking efficiency, and black holes could reach gargantuan sizes far earlier than expected. The universe, in this view, is alive with variability, not a machine governed by unchanging laws. Reality itself may have evolved over time, revealing a cosmos more flexible and creative than humans have ever imagined. Webb may also be offering glimpses of a multiverse. If certain phenomena cannot occur under our known physical laws, perhaps they are relics of neighboring universes where rules differ. Cosmic inflation theories have long suggested the possibility of multiple universes beyond our observable horizon. Webb's anomalies might be faint fingerprints of these parallel realities, interacting subtly with our own cosmos. The idea stretches imagination, but also challenges it. If the observable universe contains traces of other domains, then reality is far more layered and complex than we can yet measure. The philosophical weight of these discoveries cannot be understated. For centuries, humans have believed that complexity, order, and life arose gradually, almost as exceptions. Webb suggests otherwise. Complexity erupted almost immediately. Galaxies, chemical elements, and potentially habitable planets appeared far sooner than models predicted. Life may not be rare, but a recurring feature of cosmic evolution. Civilizations might have come and gone, leaving traces we have only just begun to detect. Every photon Webb captures carries whispers from a universe teeming with possibility, a cosmos that has been active and fertile since its earliest moments. The telescope also challenges our understanding of cosmic order. The infant universe was expected to be chaotic, with matter slowly coalescing into structure. Webb shows defined spirals and elliptical galaxies, as if gravity and cosmic forces were remarkably efficient. Assembling complex forms with astonishing speed, the universe appears predisposed toward order, and the mechanisms behind this efficiency remain a profound mystery. Are there guiding principles we do not yet understand? Could unknown forces be shaping matter into coherent systems from the earliest moments of creation? These questions move from physics into the philosophical realm, asking not just how, but why the universe organizes itself so elegantly. Chemical findings in planetary atmospheres reinforce the sense of early cosmic abundance. Webb detects molecules like methane, carbon dioxide, and water vapor in ancient systems, suggesting planets capable of hosting complex chemistry formed at unprecedented speed. Life may have been possible almost from the universe's beginning. If civilizations arose billions of years before humanity, their signals or artifacts could be drifting through space even now, waiting for discovery. Each spectral reading, each faint glow of distant starlight, becomes a potential clue in the story of life's early prevalence. Gravitational signatures reveal yet more enigmas. Light bending indicates massive unseen structures, black holes, so large and ancient that their growth challenges all conventional models. To form such objects naturally would require eons, yet Webb observes them almost immediately after the Big Bang. This suggests either an unknown acceleration of cosmic processes or new classes of objects altogether. Black holes may not just be consequences of the universe, they could be its architects, shaping the formation of galaxies and the very flow of space-time. Speculation about variable constants adds another layer. If fundamental forces evolved over cosmic time, then star formation, chemical enrichment, and gravitational assembly could have occurred with breathtaking rapidity. Galaxies could have matured almost instantly. Black holes could have grown overnight. Stars could forge elements far faster than previously believed. Such a universe is not static but alive, dynamic, and evolving, a reality where laws themselves may shift with time. The multiverse concept becomes more plausible in light of these anomalies. Some galaxies or phenomena might not fit our universe's known physics because they are manifestations of other domains, regions where different rules govern matter and energy. If so, Webb may have captured faint traces of other realities interacting with ours, offering glimpses of a cosmos more interconnected and complex than previously imagined. Humanity now faces a profound philosophical reckoning. Complexity erupted almost immediately, suggesting that intelligence and life may be widespread and ancient. The galaxies that shouldn't exist, the black holes that defy expectations, and the early chemical signatures are not contradictions, they are invitations to expand our understanding. Every photon streaming into Webb's mirrors carries messages from billions of years ago, reminding us that discovery is less about control and mastery, and more about curiosity, awe, and humility. Webb has reshaped our cosmic vision. NASA's red alert is not a warning, but a call to wonder. Each observation challenges assumptions. Every spectrum. Next, the world's most advanced telescope took another leap forward this afternoon, as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope. NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. Far beyond the reach of human sight, the James Webb Space Telescope fixed its gaze on a seemingly unremarkable patch of sky and returned with images and data that forced NASA to sound the alarm. What Webb revealed was not merely another galaxy, cluster, or the signature of a distant exoplanet, but something so profoundly unexpected that NASA issued a red alert. This wasn't routine caution or technical jargon. It was a direct acknowledgement that something in the depths of the universe had defied all predictions and forced scientists to reconsider assumptions they had held for decades. The scale, the structure, and the very nature of what Webb detected carried implications that reached far beyond astronomy into physics, cosmology, and even humanity's place in the cosmos. Before we start, smash the like and subscribe buttons for more updates. The James Webb Space Telescope was designed for discovery at the very limits of light, peering into epochs of cosmic history never before observed. Its unprecedented sensitivity allowed it to capture light stretched across billions of years, revealing the first stars and galaxies that flickered into existence after the Big Bang. Yet, in this instance, Webb uncovered signals that didn't belong to that expected story of early cosmic formation. The telescope detected objects that appeared impossibly massive, structured, and bright, existing at a time when, according to standard models, the universe should have been too young to allow such complexity. What should have been small, primitive gatherings of gas instead showed the fingerprints of fully formed galactic systems, as if cosmic time had fast-forwarded billions of years in defiance of every established model. The implications of such a finding were staggering. For decades, cosmology had been underpinned by a timeline. The Big Bang, followed by a gradual cooling, the condensation of hydrogen into stars, the slow buildup of galaxies, and eventually, the large-scale structure of the universe. But Webb's deep field observations suggested that the universe had achieved maturity in its infancy. Galaxies that should not exist so soon after the beginning of time were sitting there in the data. Their light unambiguous, their presence undeniable. If verified, this would mean that our understanding of dark matter, dark energy, and the very physics that governed early expansion would have to be rewritten. NASA's red alert was not simply a warning for astronomers to pay attention. It was a recognition that Webb's discovery had overturned one of the central pillars of modern science. The cosmological constant, the equations of general relativity, as they pertain to universal expansion, and even quantum models of particle interactions, in the earliest seconds of existence, suddenly seemed incomplete. The telescope had unveiled not just galaxies, but a paradox, a cosmic riddle written across the sky. Equally astonishing were the signals Webb picked up in wavelengths that hinted at chemical signatures far more complex than expected, within the atmospheres of distant exoplanets and even in interstellar gas clouds. Webb's instruments detected elements and compounds usually associated with biological processes or advanced chemistry. These weren't definitive signs of life, but they suggested that the raw ingredients for life may have been far more abundant and available, far earlier than scientists had ever imagined. To encounter such complexity so soon in cosmic history raised unsettling questions about how common life might truly be in the universe, and whether civilizations, perhaps vastly older than our own, could have risen and fallen long before Earth itself formed. NASA's response reflected the gravity of the situation. This was not a simple discovery to be catalogued in journals and left for gradual analysis. A red alert meant that teams across the world were mobilized, telescopes coordinated, and data poured over by specialists in fields ranging from astrophysics to particle physics. There was urgency because the discovery did not sit neatly within any known framework. If Webb's detection held true, it would ripple into questions about the stability of physics itself. Could the constants we had always assumed unchanging, the speed of light, the gravitational constant, the behavior of quantum fields, be variable over cosmic scales? Could the very laws that underpin our understanding of reality shift, depending on epoch or location? The possibility that natural law itself was not fixed, but dynamic, introduced staggering implications. It suggested a universe not as a uniform stage governed by timeless equations, but as a living, evolving system where the rules themselves could adapt. If galaxies could emerge in an impossible epoch, then the processes driving them might belong to a physics we have not yet even begun to grasp. Such a realization carried not only scientific weight, but also philosophical magnitude. Humanity had long believed it was approaching a grand unification of physics, a final theory that tied together the smallest particles and the largest structures. Yet, Webb's discovery suggested that the universe was not a closed puzzle waiting to be solved, but an ever-deepening mystery with layers of reality still beyond reach. The red alert also underscored the vulnerability of our assumptions about cosmic order. For decades, the standard model of cosmology had been remarkably successful. Observations of the cosmic microwave background, surveys of galaxy and studies of dark energy's influence all seemed to reinforce the model's reliability. But Webb had shown that even the most successful models could crumble when confronted with data from the universe itself. This was a reminder that science is not a monument of certainty, but a living dialogue between observation and theory, where even the most cherished equations can be humbled by new evidence. At the same time, the implications extended beyond abstract physics. If complex galaxies existed far earlier than thought, then black holes, those engines of cosmic evolution, may have been seeded almost instantly after the Big Bang. The presence of massive black holes in such early galaxies suggested a mechanism of growth and collapse far more rapid than any theory currently allowed. These black holes would not only reshape galaxies, but potentially influence the fabric of space-time itself, creating ripples and distortions that Webb's instruments might now be beginning to perceive. The gravitational wave signatures from such ancient events could hold secrets about the very moment of cosmic birth. And then there was the darker possibility. Some theorists speculated that what Webb saw might not be galaxies at all, but structures of an entirely different nature. Exotic objects predicted by speculative physics, such as primordial black hole clusters, cosmic strings, or regions of space where different physical laws reign, could manifest as unexpected signals in Webb's detectors. If this were the case, then the telescope might have stumbled not upon an anomaly within our model of the universe, but upon evidence of realities that branch beyond our own dimensions or domains where spacetime itself takes on unfamiliar forms. The red alert symbolized more than discovery. It symbolized disruption. It was a call to scientists and humanity alike to face the possibility that the universe is stranger, faster, and more unpredictable than anyone dared imagine. It forced a reconsideration of our timeline, of the origin of matter, and of our own trajectory within this vast cosmos. If life could have arisen so early elsewhere, then we are not unique. If the laws of physics themselves are in question, then even the foundation of technology and knowledge may rest on shifting ground. The James Webb Space Telescope had already been hailed as a window into the beginning of time. But in this moment, it became something more, a mirror reflecting back the fragility of human understanding. NASA's alert was not a gesture of panic, but of humility, a recognition that what had been detected lay outside the boundaries of present comprehension. It was both a warning and an invitation, a reminder that the search for knowledge is not a path toward final answers, but a journey through ever-unfolding layers of wonder. In the glow of that red alert, one thing became unmistakably clear. Humanity now stood on the threshold of a new cosmic narrative. The universe had spoken through light carried across billions of years, and what it said was simple yet profound. We do not yet know the full story. The unimaginable had been glimpsed, and it was only the beginning. The images that streamed back from the James Webb Space Telescope shook the foundations of everything scientists thought they understood about cosmic history. Where the darkness of deep time should have shown only faint glimmers of infant stars, Webb revealed entire sprawling structures that should not have existed. The red alert issued by NASA was not the language of routine discovery, but the acknowledgement of a rupture. A fault line cracking through the very models that guided our comprehension of the universe. It was the moment when the cosmos itself revealed that it is far less obedient and far more complex than humanity's calculations had ever anticipated. The magnitude of this revelation begins with the nature of Webb's design. Built to replace the Hubble Space Telescope, Webb was engineered with precision instruments to see the faintest traces.